So lately, I have been looking for a calculator, a desk calculator. I've been feeling rather nostalgic for not having um, my my calculator from university. So I've been looking for a desk calculator, and I think I found one. The Sharp Compat 242 desk calculator with a 14 character nixie tube display, if you can believe it. Nixie tubes in a calculator. Yeah, the Sharp. Oh, let's get a little less glare on that. The Sharp CS242. Now, that serial number should be in there somewhere. But yeah, 6600. This was there was a run of, well, maybe 7,000, 9,000, I don't know. The highest serial number I've seen is 9,000. And yeah, there it is. We are going to take a look inside this thing and see what makes it juice, because that is just going to be so much fun. So let's see how we get into one of these. Screws on the bottom. I'm sure it'll be pretty straightforward. Yeah, 4 screws on the bottom, and then the case will probably pop apart. So we'll be back. And there we go. So it's got a fairly beefy power supply in order to deal with the nixie tubes. And let's see, how does the keyboard attach over here? Okay. And look at that. 14 character nixie tube display in all of its glory. You know, reading schematics gives you some idea of what something does. Look at the chassis here, embedded chunks of brass. But until you really see the thing built 1 or 2 times, you don't really understand everything that's going on, I think. Manufacturing it is part of the challenge, for sure. So yeah, look at how nice it just sits there like that for servicing. These things probably just pop out. Designed to be serviced. Designed to be serviced. Oh no, it's a edge connector. And that pops off there. And now we've got $1,065 NA. So there's a connector back here. And then underneath the chassis there is a door. So that must be an interface port on this board. Okay, so obviously motherboard. This is keyboard input. I'll have to do some digging to figure out what kind of signaling or technology there is between the keyboard and this. But that's the edge connector for that. That's the edge connector for the display. To do some research on how an actual nixie tube works, well, I'll look at Dave's video. He's building a board, so I should be able to get some good hints about how those are supposed to be designed. And yeah, let's look up these transistors and these chips and see if we can't figure out how this thing runs. Because now that we've got it part in its sub-assemblies, it should be easy enough to now take a look at each one. So the only thing I could find out about these things was that it's a calculator chipset. That's all they say on the page. I couldn't find a data sheet for them. I do see that there has been one of these things replaced, so I wonder how that happened. But other than that, what I'm thinking is this part, the main board, could be replaced with a modern calculator, and the top of this guy could be modified with some additional keys. So we need to flesh out this area a bit. These might have to move to some other position if they're going to get used at all, although maybe a brightness control. And that one, maybe convert it into a RPN if you've got the right software, right? So takes up a little extra space on your desk. You have to plug it in using a normal plug-in, but I think that might be an interesting project, or just leave it as the piece of computing history that it is. I don't know. I'm glad I have it though. So let's take a closer look at the nixie tubes. Let's get some light on the subject here. So we have capacitors and transistors that are some sort of power switching circuit, because power is coming in here. Power is coming in here from the power supply, and it's being distributed across the front and then going into each of these tubes is my guess right now. Data's coming on the back, and look at how beautiful that circuit board is. Hand drawn by an artist, photographed or through lithography, put onto a piece of board and then etched. It's gorgeous. It's absolutely gorgeous. It's a work of art. That is right there. It's like got waves coming out of the board. Just this keyboard is a marvel too. It's got like solid weighting on all of the switches and nice hefty spring action. You know, the keys are not even wobbly at all, and I'm sure they still make contact. There's a couple of keys in the number pad that are a little sticky, but you can just get some lube in there. And then these are the it's a multi-position resistor bank. It looks like, or multi-switching to a resistor bank. Amazing piece of hardware. It'll be hard finding keys that match the feel of these keys, but I'm just gonna have to keep my eyes out. Okay, this is how you connect the keyboard to the chassis. Connector. 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 That's pretty crazy, the amount of miniaturization we've gotten so far. Oh, almost a modern power cord. So before hacking a power cord for this, I wanted to check the polarity, and yes, center pin's ground, so the standard computer interface. Okay, let's see if we can't get this thing to power up with my hacked little cord here. Whoa! Contact! Ah, but the keyboard doesn't work. Huh. Darn it. Okay. When you look at this cable connector up close, these cables are tied by hand. They go all the way through to tie up this cable harness, which is pretty awesome. But I digress. I think that there might be a problem with the keyboard or the keyboard driver, but that's okay. That's okay, because we could just replace the keyboard, hack what that should be doing, and replace the keyboard driver circuitry at the keyboard level, because we're going to be adding buttons and things like that, and it looks like it's going to be hard to find space, although it gives there's a nice metal chassis in there. Anyways, yeah, so I reseated the board. Maybe that's it. I doubt it. Yeah. Oh, whoa, whoa, whoa. Look at that. Okay. Oh, this is going to be so much fun. Oh my goodness gracious. What do I have to do to reboot it? There we go. Yeah, this is going to be a lot of fun. So I think on ATX power supplies you have 4 screws. This one has 1, 2, 3, 4, 5. And it lifts out just as easy as any power supply would from a computer today. Beautiful engineering. Oh my God. Nice.